this is a function. Why? Each input gives one unique, I shouldn't say unique, gives one output. Now, what is the domain? Domain I have been drawing in what? Red? What is the domain? 1, 2, 3, 4. Are there any other values of the domain? No. Notice that is different than our hours up here, right? Because you can work any number of hours, minutes, and seconds between 0 to 40, can't you? But here, I can only be 1, 2, 3, or 4. Everybody understand? What's the range? 3, 6, 9, 12. Now, once you have made this split, they are no longer ordered pairs. All right? What I mean by that is, in this case it works, but it doesn't always. 1, 3 is a point on the graph. But once you've split them, you cannot think of them that way. Is everybody cool? All right, let's look at the next one. 4b, function or not? No. Why? Input of 0 gives how many outputs? 2 outputs. What are they? 1 and -1. Everybody understand? What's the domain? 1, 0, -1. You do not need to write 0 twice because it is just a single value. Now these squiggly brackets are what you're supposed to use when you're doing set notations. It's actually this bracket. The devil horns from the old emojis. But I don't draw those very well unless I really think about it. So I just do squiggly brackets. Because I'm lazy. Some people like to draw these this way. They go down, they do a little loop, then they go down. I don't care. Just suffice to say it is not that nor that. Okay? What is the range? 0, 1, -1. Now, please notice the way we've written those. Why did you guys write them 1, 0, -1 and 0, 1, -1? Because that's the order they were written here, yes? That's not how we should write them. How should we write them? Least to greatest. So what should this really be? It should be -1, 0, 1. And what should this one really be? -1, 0, 1. And then that illustrates what I was just speaking of. Is -1, -1 one of our points? No. Because once we split into domain and range, we are no longer thinking of ordered pairs. Everybody with me? The domain is just the elements of the input. It has nothing to do with the output. All right? Okay, what about C? Yes or no? Yes. Why? Input equals 1 output, again. And now, properly, what's the domain? 2, 4, 6, 8. Who do we appreciate? Math, math, rah, rah, rah. What's the range? 3, 5, 7, 9. Yeah? Is everybody good when we list them? Great. Now what happens in 4D when they're on a graph? You just list them. Because every one of those blue points on that graph is just a pair of coordinates, right? So, What is my domain? Is domain usually graphed on the x or the y-axis? X. So there's an x value, yes? There's an x value, yes? There, and there. So what is my domain? -3. And what is my range? There on the y. There's 1, 2, 3, 4, 5, and 6. What's that one? Excellent. Is it a function? No, it is not. Why? At -2, there's 2 outputs. Right? Now, what is different between A, B, C, and then D? A, B, C gave you coordinates. D gave you a graph, yes? Right? That's the only difference. So, that opens up this case, the vertical line test. The vertical line test only for graphed relations. This only works when it's graphed. And what it says is a vertical line will only touch a graph once in a function. So, here we draw this, and we're going to draw a smiley face like that. Over here, we're going to draw this, and we're going to draw a bracket. Then we'll take a vertical line, which I'm going to choose a funky color for. I like orange today. And I slide that vertical line along the graph. And how many times does it hit the red line at any given second? Once. So is the red line a function? Yes. Come over here. How many times does it hit the red line? Twice. So this is a relation. Function. Relation. Is everybody good? Now, does it have to be a line? No, it'll work right here, won't it? If I draw my vertical line right there, and I slide it along the graph, what happened right there? It hit 2 dots. So even if it's not a line, if it's on a graph, you can use the vertical line test. Is everybody cool? All right, now to recap. Where do I find domain values? The independent variable, which is 99 times out of 100 on the x-axis. That's where it should be. Now, sometimes people turn graphs around for looks, right? Because it looks nice to turn the graph, right? All of you have seen graphs, bar graphs that have gone sideways, yes? That is a turned graph. The independent variable is still, it's on the y-axis, but it's because we've turned the graph sideways. Everybody with me? Let me give you an example of that so it doesn't confuse the issue. Catherine, Marianne, and Sophie. They all have a height, yes? Catherine is the tallest. Marianne is the shortest. Sophie is the middle, yes? Their height depends on who I'm speaking of, yes? But that graph is easily turned sideways. Oops, Sophie is the middle one. Marianne is the short one. Catherine is the tall one. And height is here. That graph works, doesn't it? But this is still my independent variable, even though it's been put on the y-axis. Is everybody good? All right. It's the only graph that people really do that for. You wouldn't really put a line graph sideways like that. It would look weird. But people like to turn their bar graphs sometimes. Pie graph doesn't matter. Scatter plot. I guess you could do this one sideways if you were doing, if you were just putting heights without the bars. I guess you could put it sideways again, but it would look weird, right? It's really for looks. All right. Where did we get to in our recap? Where's the domain live? X. We talked about that. So where's the range live? Y. All right. So let's go down and start looking at, is this a graph? So can I do the vertical line test? Yep. Is it a function? Nope. Why? There's 2 dots where? At -1 and at +1. So this is a relation. Why? 2 outputs at -1 and at +1. Right? Okay. Where do I find the domain? On the x-axis. What's my lowest x value? -3. There's a dot right there, right? -3. What's my next x value? Then what? Then what? 0. Then what? Then what? Then what? 3. -3, -2, -1, 0, 1, 2, 3. Now, some of you will say to me right now, Mr. Myers, it goes from -3 to +3, and it hits every number. Why did I have to list them? Brendan? Yeah. I went along the x-axis. Why did I have to list 7 numbers? Ashni? Yes, there are no fractions here, are there? If I input 1.5 or -0.5, do I get any output? No. So that's why I gotta list it. Everyone cool? All right, let's get rid of the domains. And let's look at the ranges. What are they? -2, -1, 0, 1, 2, 3. Do I have to list them? Yes. -2, -1, 0, 1, 2, 3. Notice there is one less range value than there is domains. So, this is another example of why we cannot think of these as ordered pairs anymore. Is everybody cool? Is this a graph? Can I use the vertical line test? Is it a function? We are good, yes? All right. Great. So this is a function. How is it different from the previous one? It's a line, isn't it? The other one was just dots, yes? So, what is my domain? What is the lowest x value? -3, correct? What is the highest x value? +3, correct? Do I list them? Why not? Because it can be any number from negative 3 to positive 3, yes? How many numbers exist between negative 3 and negative 2? Infinity. Would it be possible to list them? No. So when it's a line, we do this. There is an x value all the way along. Right? At any point, I get an output. Yes? So because I list it all the way along, the x's must be between negative 3 and positive 3. Negative 3 is less than x. X is less than 3. Does everybody understand that? Now, that dot right there is colored in. How many of you remember grade 9, this scenario? X minus 2 is less than or equal to 7. Oh, crap. How many of you remember that scenario? Right. How do you solve it? X is less than or equal to 9, right? Then you put it on a graph. 9, what did you do there? You circled it. There's an equal sign, so what do I do there? I fill it in. Because that means 9 and everything less than 9 works. What if there was no equal sign there? What do I do with this dot? You do not color it in. Is that dot colored in? So, does that mean negative 3 is included? Yes. So what must I put here? An equal sign. Is that dot colored in? So does that mean positive 3 is included? So I must put that line there. And then technically, you write this out with some really long notation. You write it out like this. X such that X is a set of, like, it's horrible. You don't need to know that notation for grade 10. Okay? All we do for grade 10 is leave it like this. You may want to put the squiggly brackets, and I'm happy with that. When you see your textbook work, you will see some of the weird numbers written out. All right? I'll explain it when we get to it. Because you don't need to know it for right now. Everybody cool? Yes. I'm sorry, I can't hear you. Which? This? The vertical line? What? The vertical line test? You just, okay. Since it's a vertical line, it's passing through the x's, right? The x's are my inputs, yes? So at every point along here, that's an input of negative 2, or of positive 2, right? How many outputs does it have? 1. That's why it's a function. If it wasn't a function, the line would hit twice. This blue line might do this. Then it hits twice, so it's not a function. Because at positive 2, there are 2 outputs. Okay? All right. Yes, Suhani. Well, we haven't gotten to range, Suhani. We're still talking about domain. Is everybody good with domain? Does everybody understand this? This is called set notation. We can also write this in what is called interval notation. And interval notation is different. Interval notation looks like this. What's the lowest number? Negative 3. What's the highest number? Positive 3. Is this negative 3 included? Yes. So we put a square bracket. Or as my good friend Zachary Goulet calls it, a hard bracket.
Oh my gosh, Zachary was my best friend in grade 3.
Okay. He just calls square brackets hard brackets and round brackets soft brackets. I'd never heard it before, but I like it.
That's so funny.
I've never, ever heard it. I don't know who taught him that. All of you went to school together since kindergarten. What teacher did you have?
His dad.
Oh.
His dad's a teacher.
Oh, I didn't know that at all.
Yeah, he was a grade 5. He had a pet snake.
He was your grade 5
He
teacher?
wasn't my grade 5 teacher, but he kept a
Oh.
character snake and everything. Oh my god.
Okay. Anyways, all right. Is this 3 included? So what kind of bracket? Hard bracket or square bracket, depending on what you want to call it. Actually, that's a bracket. That is a parenthesis. No. That's a bracket. That's parentheses. So really what I could say is bracket, -3, comma 3, bracket. Now you must be careful here. Is that an ordered pair? No. -3, 3 is not on the graph. So you got to watch out for that, right?
Not on the graph?
It's not.
Negative what?
-3, 3 would be right here, yes?
Yeah.
Is it on the graph?
Oh, on the okay.
All right. Now, what then is the range? How do you think we find it? It's exactly the same way, except we are looking where? On the y-axis. What's the lowest y value, Sean? -2. How far up do I go? +3. Now, a lot of kids make the mistake of stopping where the graph ends. That's a mistake, because you can quite plainly see that there are outputs above that. So, what is the lowest value here? -2. Is it included? So what symbol do I put here? Less than equal to. Less than or equal to what? Y, which is less than or equal to? 3. Squiggly brackets. How would I write it in interval notation, which is what this is called? Hard bracket. Oh, Zach will be so happy. -2, comma, 3, hard bracket. Now, this is only applicable for lines. We could not do this with this graph, could we? Right? Because there are no inputs and outputs between that or this way. Does everybody understand? Catherine.
So this is like, just speaking hypothetically, if you drew a line with all those dots,
Yeah.
you could do that.
Yes, if I did this, you could do interval notation or set notation. Everybody good? Sweet. Scribble, 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 erase, erase, erase. Turn the page over to 180. What's different? 2 lines. If this line was not there, how would we do our domain of what is there? What's the lowest value? No, look again. -30. Is -30 included? How do you know? Closed dot. So I have to use the equal sign. X. X is less than what? -10. Is -10 included? No. Huh? Everybody cool? Okay. How would I write that in interval notation? Hard bracket. -30, comma, -10. Soft bracket. Huh? Yes, you've learned this. Because the negative 10 is not included. I can go up to negative 10.000000001, but I can't hit negative 10. Absolutely. Because negative 10 is not an input here. There is no output. The point negative 10, 0 does not actually exist. But I get so close to it because I can come up to 1/4,000,000th of a point away from it. I have to draw it this way. Cool? All right, everybody good? Okay. What then is the range on that first part? Negative 20 less than or equal to y less than 10? 0. And what would its interval be? Is everybody good with that side of the situation? Ganika. Negative 10, negative 20. 1, 2. We're looking at the range values. Okay. Everyone good? Now, wait a minute. There's another whole side to this, yes? What happens over here with this side? What's the lowest domain? 0. Do I hit 0? Why? Because it's closed dot. Less than or equal to x. Up to what? Less than 30. Why? Open dot. Now what is that in interval notation? Hard bracket. 0. 30. Soft. Yeah? Okay. What's the range? 10. Do I hit 10? No. Up to what? Do I hit 30? Yes. How do I write it in the other one? Now, because I have more than one set, I must use this symbol, a U. Because it is this set union with this set. Everybody good? There's a whole bunch of different rules about what you do with that U, but in grade 10, this is all we're going to talk about. It's a big U. Yeah. It's this set union with this set. Because there's two of them. Everybody good? What if I had a third line out here? There would be another union. Everybody cool? All right. Function or not? Function. Why? The input output. If I draw my vertical line, how many times does it hit? Once. Right? All right. D is weird. Yes, Catherine.
For C, does it matter if there's like a time where the vertical line just touches nothing?
Yeah, of course not. It's still a function. There's no inputs or outputs there.
Okay.
All right. What's the domain? Look again. Negative 6. Is negative 6 included? No. Now, let's start along here. What happens right here? This line stops at negative 3. But what happens immediately at negative 3? 2.999999999999999999999999999999999999999999999999999999999999999999999999999999999999999. It starts again, doesn't it? So I keep going. Then I hit there. What happens at 3.11111 or 3.00000000001? It starts again until it ends. Does everybody see why? Great. Who just said no? Why? What part of this have I lost you on? Okay. You all know how numbers work, right? This is -3. The next number is -2 point an infinite amount of 9s, yes? Okay. So it starts right away. And it continues to here. The next number is 3 with an infinite number of zeros and then a 1, which is starting right there. So it continues on. These points are not stoppages because it continues on immediately. Yes? So -6, not included, x up to what? +6. Is +6 included? Yes. So, now put that in interval notation. Soft? Yeah? Yeah. What's the range? 3, 6, 9. Anything else? Did I color anything? So can I use interval notation? Yes or no, guys? There's 30 of you. Could I use interval notation up here when I only had dots? So can I use interval notation here when I only have dots? So what's the range? 3, 6, 9. That's coloring because the whole axis is colored. This is dots. Now, is it a function? Let's get out our vertical line and check. Selena, you have said no and yes 7 times each. Which is it?
The relation.
Be strong. Give me an answer. What's the worst that can happen? I will say no, and you will lose a ton of marks. No, you won't. Which is it? No, zip it. Selena is going to choose. It is a function because, yes, that hits twice, but is that dot colored? So is 3 actually hit twice? No. Because 3 does not occur up there. What does occur up there? -2 point infinite number amount of 9s. 2.9 is the closest thing to 3. And an infinite number of 9s would be the closest thing to 3. But not 3. Because 3 is 3. 2.9999999 is not 3. It's almost 3. Is everybody good? Yes? Going once? Going twice? Yes, Suhani. I don't know what you... If the lines are like that, it would just be one line. You are making no sense. Ask me a question. Which lines? There's a vertical line on there. There's this horizontal domain line. What lines are you speaking of? Okay. The graph. The graph. Yes. What about it?
So if you come across another question that's just like this, so the lines would continue with that.
What lines? These lines end here and here. I don't know what you're asking me, Suhani. I want to answer it. But you are not asking me something I can answer. What lines would continue? You can see the lines end and begin.
The question is, why would you
Oh, you mean why do I not use a union?
Yeah.
Okay. Because again, this starts here, goes to here, and then starts again immediately. There is no gap. It is a solid domain from -6 to +6. There are no gaps. In this question, there was a gap. There are no domain values between -10 and 0. In this question, there are domain values all the way along. Okay? Sean. If this dot was colored in, then it's not a function. If this dot wasn't colored in, then yeah, you could write this still, but you would want to write x cannot equal -3. Because it can equal -3 point infinite number of zeros 1 and -2 point infinite number 9s. But it can't equal 3. Everybody cool? It's the first time that's ever been asked. Nice job. Everybody cool? All right, you have something like 15 minutes left in class. What's the next page? Can I see it, please? Oh, yeah, it's those things. You have 12 graphs on the next 2 pages. Please go to them because the photocopying is a little messy on them. And you can't tell what is going on a couple of them. So please go to them now, look at them now, so I can sort this out with you. All right? Give me a second. I got to erase some ink notes. And you can all look at my good friend Gervine right now. Oh, it's only your desk talking right now? You guys are liars. I have kids. When you walk by video stores in the mall and they have those screens up there and there's a TV, you all stop. Stop it. Every single one. When you walk in the door in Safeway and there's the security monitor, you all walk through that door. Watching up there. Don't give me any of this horse crap. Or you put yourself on Instagram for the entire world to see, but for 30 people to see you now. No, I'm shy. No. Oh, but here I am jumping off a garage and breaking my arm. Not that you would jump off a garage and break your arm. But there are people in here that would do that and quite happily put it on Instagram. But if I do this, no. A few hands were up before that little rant. What? No? All right. Okay. This question, closed dots all over the place. This question, closed dots all over the place. This question, this arrow flattens out. It continues, but it continues flat. Everybody cool? Oh, I forgot to tell you what I want you to do on this page. 3 things. 1, function. Yes or no. 2, the domain. 3, the range. In, set, and interval, but only if possible. Because there are some graphs on here that are just dots. Everybody cool? Set or interval. So the x less than, or bracket. Everybody good? Number 4, that is an open dot. Yes, Brendan?
So what would you write for number 3 if they kept going?
I'm going to talk about that in a second. It's like you read my mind. Get out of my brain. This is an open dot. This arrow flattens out. Straight horizontal. This guy's closed dots everywhere. Everybody good? Okay. Next page. Open dot at the end of this guy. Number 3, notice there is an arrow. It is flat. Open dot there. I want it to be an open dot. Everybody good? This is all being recorded, so don't worry. Down here, you should be able to see that these 3 are all open dots. I don't know if the photocopying works, but I'm putting them in there now. This guy, you should be able to see that's an open dot. And then this guy is done. It's a... Nobody's ever said that either. Good day today, Honors 10. All right, we all good? Now, stop. Brendan just asked a very good question. And we are going to use, like I said, would I ever leave this much white space? No. I forgot to do this, actually. So, make your graph. Draw a line. It doesn't matter what it looks like. I'll fix it in a second. Draw that with an arrow. -4. 5, right? Everybody cool? You're just drawing a line on a graph, Suhani. All right. What is my lowest domain value? -4. Do I hit -4? Yes. What does this arrow mean? It continues to the right and down. How long? Forever and ever and ever. So, it will go up to what? Infinity. Will it get to infinity? No, because you can't get to infinity, so it will never equal infinity. Everybody with me? How would that look in interval notation? Hard bracket, -4, infinity, soft bracket. But in this case, there's another way we like to write it. X is greater than or equal to 4. Because every x that's bigger than -4 works. This is just another version of this. Because there is no upper end, so all the x's greater than -4 work. Is everybody cool? Okay, what's the range? Oh, that should have been red. I like to draw my domains in red. So what's the range? What do I start with? No. The lowest value. -infinity. Will I hit it? No. Why? Less than or equal to? 5. 1, 2, 3, 4, 5, right? Interval notation, -infinity, that's a bad infinity. -infinity to 5, hard bracket. How would I write it? Oh, damn it, that's supposed to be blue. You would think I could, but
Why don't you just highlight it in blue?
now, how would I write this better?
Why greater?
Y is less than or equal to 5.
Do you put brackets around that at all?
Don't worry about it. Is everybody cool?
Wait, do we have to write that second?
If infinity is involved, this is a lot easier to write than this. But I don't care. But some textbooks will do this. You need to understand that this equals this. All right? Everybody good? Okay, that's your job tonight. Those 12 questions. You're going to have to write a little bit, but not much.
Can I go to the bathroom?
If you need to, yes.